Hello everyone, my name is Yuso. Our research topic is fog computing. We're going to go through some of the abstract here, and later on my team will also talk about the more details about the fog computing in terms of the research goal and the solutions. Um, so these are some of the abstract of the cloud computing, fog computing. Limitation of cloud computing. We're going to talk about growth of the IoT, and then we talk a little bit about the benefit of fog computing. Okay. Limitations of cloud computing. With such high demand in cloud computing, it requires quite a bit of huge infrastructure costs to build up all these data center as well as maintaining them. So the investment for such build up it's huge, and the second one is the connection and bandwidth bottleneck. With that many of devices out in the internet, every single one of them trying to connect to the cloud, and they rely heavily on internet access. Any interruption in terms of powers or connectivity will have a big costly impact on the whole infrastructure. Lastly is the security shortcoming. Since with the popularity of sharing or using the VMs, and the basic infrastructure right now of the cloud is with the centralized data center with and then leasing resources to the multi-tenants. Any breach of one particular server or any conduit they sharing, we have a major impact on multiple clients or tenants. Next, we're going to talk a little bit about the growth of IoT. IoT, which is Internet of Things, and has grown rapidly for the last couple of years. You probably have multiple IoT, with you already, your phone, your smartwatch, and then in your home you might have a thermostat that connects to the internet. So these are all the IoT, and the growth of IoT has just been, rapidly increased as technology moving forward with the new products keep coming up to the market, and the back-end demand to run these IoT also increase because they constantly require internet access and some kind of server or data storage behind to support these IoT devices. Next, we talked about benefits of fog computing, right? So with the traditional cloud computing, like I said in the previous slide, everything is connected to the internet, everything relies on a centralized server, and the resource requirement for such platform is huge. With fog computing, we can distribute these resources at the different level, so we would rely less on the connectivity as well as the server resources. Okay, the main goal of the fog computing is reduce the amount of latency because again, with that many devices out in the internet trying to connect to the same server at the same time, the network speed and bandwidth requirement would definitely cause latency since the traffic is so congested. The next one, the benefit would be that since the data is partially or sometimes fully processed at the fog computing level, so we require less of the data from the server and less CPU processing from the server. And with that, it would greatly increase the real-time performance of the network as well as the CPU. And lastly, the security also, the, with fog computing, the security model is also a little bit more secure because it has less footprint throughout the internet, meaning that the data travel less in the distance throughout the public domain. That way, you have less subject to any kind of form of security attacks.
Hello everyone, I'm Suthar, and I'll walk you through the introduction of our research topic, fog computing. The topics that we'll be covering are Internet of Things, what is fog computing, cloud versus fog, and why fog computing. Before talking about fog computing, let's understand what Internet of Things is. The Internet of Things, or IoT, refers to a system of interrelated, internet-connected objects that are able to collect and transfer data over a wireless network without human intervention. These objects range from ordinary household devices to sophisticated industrial tools. With every second, 127 new IoT devices connecting, the experts are expecting more than 75 billion devices to be connected to the web by 2025. Now, let's understand what fog computing is. Now, when we talk about fog computing, the most obvious question is, what is fog? The first thing that comes to mind is this: a cloud that is closer to the ground. Well, yes, we can think of fog computing the same way. The fog extends the cloud to be closer to the things that produce and act on IoT data. These devices are called fog nodes. They can be deployed anywhere with a network connection, and any device with computing, storage, and network connectivity can be a fog node. Examples include industrial controllers, switches, routers, embedded servers, video surveillance cameras, etc. Fog is seen as a new cloud, and many believe that it is here to replace the cloud. But really, it's just an evolution or extension of the cloud. Now, let's see some of the differences between traditional cloud and fog. Architecture. Cloud architecture is centralized and consists of large data centers that can be located around the globe, 1,000 miles away from client devices. Whereas fog architecture is distributed and consists of millions of small nodes located as close to the client devices as possible. Communication with devices. Fog acts as a mediator between data centers and hardware, and hence it is closer to the end users. If there is no fog layer, the cloud communicates with devices directly, which is time consuming. Data processing. In cloud computing, data processing takes place in remote data centers. Fog computing and storage are done on the edge of the network, close to the source of information, which is crucial for real-time data control. Latency. In cloud, moving data from network edge to the data center for processing adds latency, whereas fog provides low latency. Connectivity. A cloud system collapses without an internet connection. Fog computing uses various protocols and standards, so the risk of failure is much lower. Security. Fog is more secure system than cloud due to its distributed architecture. Now you would think, why do we even need fog? The reason is today's cloud models are not designed for the volume, variety and velocity of data that IoT generates. As I mentioned earlier, we are expecting more than 75 billion of devices to be connected in future. So there is going to be exabytes of data to be handled. IoT devices generate data constantly, and often the analysis must be very rapid. So for handling the data generated by IoT devices requires a new computing model. This is where fog computing comes into the picture. The main requirements are to minimize latency, address security concerns, operate reliability, conserve network bandwidth, collecting secure data across a wide geographic area with different environmental conditions. This brings me to the end of the introduction. Now I'll pass you over to my teammate Shriya, who will further explain our research goal.
And today we'll be talking about the research goal for fog computing. Under the research goal, we'll be covering topics like the hierarchical architecture of fog and edge computing, how does fog computing reduce the cloud workload, fog security, and what are the benefits and shortcomings of fog computing. Now let's look at the hierarchical architecture of fog computing. So fog computing extends cloud services to the network edge by introducing fog layer between the end devices and the cloud. As you can see in the first figure, it's basically an hierarchical architecture of fog computing. The hierarchical architecture is composed of three layers: terminal layer, fog layer, and cloud layer. Terminal layer is the layer that's closest to the end user, and it consists of various IoT devices like sensors, mobile phones, smart vehicles, so on and so forth. Fog layer is a layer located on the edge of the network. Fog computing layer is composed of a large number of fog nodes, which generally includes routers, gateways, switches, access points, etc. Now, the next is the cloud layer. The cloud computing layer consists of multiple high performance servers and storage devices. It also has a powerful computation and storage capabilities to support extensive computation analysis and permanent storage of enormous amount of data. In this architecture, each end device or smart object is connected with one of the fog nodes by wireless access technologies or wired connection. The fog nodes can be interconnected by wired or wireless communication technologies, and each fog node is linked into the cloud by the IP core network. Next is the edge computing. Edge computing is also a computing model that extends cloud service to the edge devices. It also allows computation and storage to be performed on the edge devices itself. That would basically save us a round trip back to the cloud, save us a round trip to cloud and back. So figure 2 shows the architecture of edge computing. These edge nodes can be composed of smart sensors, smartphones, and special edge servers as well. Now let's see how fog computing reduces the cloud workload. So there are billions of connected IoT devices that generate like huge amount of data every second, and there is a need to store, process, and analyze the data that is generated efficiently. The data center plays a vital role in IoT, but the utility of cloud computing gets affected by parameters like delay in response time, bandwidth, energy consumption, and etc. To overcome such limitations, the concept of fog computing was introduced. In fog computing, the data is managed near to the devices. This reduces the reliance on the cloud based platforms and the requests from the devices which are time sensitive and also that require quick responses are processed by the fog nodes themselves and are not kind of transmitted over to the cloud for processing. This reduces the data movement across the network, resulting in reduced congestion and elimination of bottlenecks resulting from centralized computing system. Let's move to fog security. Now, Internet of Things devices are required to quickly process large amount of data. So this wide range of functionality driven applications intensifies many security issues regarding data, virtualization, segregation, network, monitoring, so on and so forth. So potential security issues of fog platform are inherited from the cloud platform as you can see in the figure. So, fog computing platform and the deployment of security solutions on various components of the fog system. This figure shows how and where proposed security solutions can be placed in the need of like eliminating various security flaws. And by having these protocols in place, we kind of ensure that we have the security in place for our fog computing. Now, let's move to the benefits and shortcomings of fog computing. Along with benefits, we do have few of the shortcomings that come with fog computing. And now let's quickly talk about the benefits. Privacy. So as you can see, the sensitive data is analyzed locally, and instead of sending them to the centralized cloud infrastructure, so this way the privacy stays intact. Second is productivity. The fog applications can be easily made by developers, and they can be deployed wherever they want after the development. Third is security. Fog computing has the capability to connect like multiple devices to the same network. Because of this, the operation takes place at various endpoints in a complex distributed environment, and this makes it easy to identify potential threats before it affects the whole network. Bandwidth. Now, because the data is processed locally instead of the cloud, there is very little need for the bandwidth requirements. Same goes for latency. As the data is processed locally, we have latency savings. The data can be processed at the nearest data source that is geographically closer to the user. Now, let's talk about the shortcomings of fog computing. The first is complexity. Due to its complexity, the concept of fog computing can be difficult to understand, and because there are like multiple devices located at different locations, it could add more complexity to the network. Second is security. Now, there are numerous devices present in a fog computing architecture. There are chances of this fog nodes to be in a less secure environment, which makes hackers like easily impose fake IP address trying to gain access to them. Maintenance. Unlike cloud architecture, where the maintenance is quite seamless, that's not the case in fog computing. Because we have controllers and storages distributed across various locations in the network, it needs more maintenance. Last but not the least, power consumption. The number of fog nodes present in a fog environment is directly proportional to the energy consumption, which means that these fog nodes require high amount of energy for them to function. That's what we have from Research Goal. Thank you.
Hello everyone, this is Vivek Baskar. So far we learnt about cloud, IoT devices, fog computing, differences between them, and also the advantages and disadvantages of fog. Now we will talk about the solutioning of fog computing. Before that, we must understand the architecture of the systems before fog computing. The below diagram depicts how cloud and IoT devices are tightly coupled and also complement each other. One hand, IoT devices take advantages of computation and resources of cloud platform in the form of technology constraint. Cloud provides optimal solution to implement IoT device management and composition as well as application to process the data produced by the devices. On the other hand, cloud can benefit from IoT by extending the scope to deal with new real world services utilizing cloud's distributed and scalable computing. This integration of cloud and IoT devices brought more sophistication to service offered other than the conventional cloud services like platform as a service, infrastructure as a service, and software as a service. Here are few smart services which was led by cloud IoT integration. All these smart services brought in complexities like security, network bandwidth, latency of service call, data management, and other physical constraints on the devices. With the introduction of fog computing, which solved most of the cloud IoT complexities by extending cloud computing to the edge of the network while providing low latency, location awareness, and real time computing support. It has been designed to support IoT applications characterized by latency constraints and requirement for mobility and geo-distribution. In combining user behavior profiling with decoy technology, which is the solution that fog computing is using to complement the cloud and extend the security to it. The best ways to explore fog computing is to analyze the use case of the fog computing devices, which makes the IoT devices to act smart and compute faster with less bandwidth and late, lower latency. So few of the use cases are listed below. So the fog computing can be used or already in use in smart grid, healthcare system, smart traffic lights and connected cars, smart building control, augmented reality, video streaming systems, wireless relay and actuator networks, intelligent transport management, and industrial commercial networking. Now let's look at size and impact of fog computing market. According to the survey conducted by Open Fog Consortium and 451 Group in the year of 2017, in four different continents, which includes North America, Europe, Australia, and Asian continents, found that fog computing is to grow by 18 billion by 2022. In that, the largest share of market would be in energy and utility sector, followed by transportation and healthcare. This will largely improve the private and public collaboration in and also in the investment in infrastructure modernization. Hardware will have the largest percentage of overall fog revenue of 51%, followed by fog application uh, at 19% and the services at 15%. Let's look at the verticals and the sector of fog computing market. So fog computing market is extended to agriculture, data center, energy, health, industrial, military, retail, smart buildings, smart cities, smart homes, transportation, and wearables. So, the fog computing proponents believe that it resolves problems related to congestion and latency. It provides computation, storage, and network services at the edge of the network. It also provides an intelligent platform to manage the distributed and real time nature of emerging cloud IoT infrastructures. Finally, fog promises to take hardware and software virtualization back down to earth where it all belongs. That's about fog computing. Any questions are welcome. Thank you.